Hello folks, welcome to my channel Java Demystified by SSR. Here comes the question number 29. What are anonymous inner classes in Java? Let's demystify this question. Anonymous inner class. Anonymous inner class basically is a nested class. A class defined inside other class. And this nested class is non-static. The non-static nested classes are called inner classes. So anonymous inner class is non-static, and this class is a local class. A local class is defined inside a method, and this class has no name. That means it is nameless or anonymous. So these are the properties of anonymous inner class. It's basically a nested class which is non-static, which is a local class without any name. So that's why it is very tough to understand, because we have a class definition but there is no name for that particular class, and we have to create an object of that particular class, and that class has to do some tasks, right? So now if you see how this anonymous inner class has to be written or specified in the program, it is like this. The anonymous inner class combines the process of instantiation and class definition. The process of instantiation of a class is with a new keyword followed by a constructor. As an example, if you see here, new followed by the class name with the parenthesis, that means it's a constructor of the class, right? So, and this constructor can be default or it can actually take some arguments. So this is the process of instantiation, new followed by the constructor. Usually we will end with semicolon, but because it is anonymous inner class, it combines the process of instantiation plus class definition. So this is the class definition. So class is a block, and in the definition we have data members, methods, and their implementations, right? So here we can actually write data members and we can actually have the methods implemented. Okay, so this is how we can actually specify anonymous inner class. So there should be new followed by the class name and the parenthesis, that means it's a constructor but there is no semicolon, and it should get continued, and this is the class definition. And here we can actually have the implementations of the methods, and finally there is a semicolon to end this particular anonymous inner class. So this is the syntax actually for writing anonymous inner classes. Now what is the purpose? Why do we have to write a class inside other class which has no name, and that too inside a method? What is the purpose? Yeah, the purpose actually is very useful. Anonymous inner classes implement abstract methods of the abstract class and interfaces. We know in abstract classes we will have the abstract methods, those are just method declarations, and there exists some class which extend the abstract class and provide the implementations for those methods. In the same fashion, interface contains all method declarations only. There is no implementation for any of the methods in interface. So there should exist some class that implement this interface and provide implementation for all the methods of interface. Because these abstract classes and interfaces cannot be instantiated. That means we cannot actually have object created for these abstract classes and interfaces. So now here comes the anonymous inner class. What anonymous inner class will do is, it will actually implement the abstract methods of the abstract class and the methods of interfaces. Because they cannot be instantiated, now anonymous inner class comes into the picture, which implement here in the definition, which implement all those methods. Okay, and it can be instantiated, so object will get created and anybody can actually call the methods of these abstract class and interfaces with this anonymous class object. That is the purpose. It implements abstract methods of abstract classes and interfaces because they cannot be instantiated. So now anonymous inner class will implement all these methods, and its objects can be created through this object. Anybody can call actually the methods of these abstract class and interfaces. And of course, anonymous inner class can be used to override the methods of the classes as well. In a class, usually we will have concrete methods, and concrete methods will have the behaviors. Now, anonymous inner classes can be used to override those methods defined by the class by extending it. So, by default, in the implementation of anonymous inner classes, inheritance is available. So let's understand the intricacies and the details of this anonymous class and how it is going to implement all these abstract methods, or how it is going to override the methods of classes with some example. So now let me go to a program. So for example, here I have a class, abstract class. This class person is abstract because it has an abstract method eat. Okay, so what it is saying, actually there is a class person and the person can eat, but what person is eating or what person can eat, that was not specified, right? Because this is an abstract method, we have made this person as abstract class, right? Okay, so now somebody has to implement this particular eat method if they are interested in this particular person class. So there should exist some class A that extends some person, this particular person, and provide the implementation object of this particular class A can be created, and the eat method behavior can be accessed or can be exhibited with the help of that particular object, right? Yeah, now the same task can be done actually by an anonymous inner class. So let's see now. Okay, so now I have a normal test class, which is actually my executable class, main class. Okay, and here I have my main method. Now what I'm doing over here is I'm actually writing an anonymous inner class over here. This anonymous inner class will implement the eat method of this particular person class. How this will happen? Okay, so we know anonymous inner class has to be written inside a class. So now I am writing inside this test class. Okay, and which is a local class, so I am actually making inside the main method, and it is non-static. Okay, so now what I'm doing is, yeah, so what is the definition of anonymous inner classes? It's a class which combines the process of instantiation and class definition. So person, new person, and of course my person class has no constructor. My abstract class has no constructor, so I am using my default constructor. Now I am not saying this semicolon because it's not possible, it's an error, because a person class cannot be instantiated because it is abstract class. Okay, so as part of anonymous inner classes, what should be done is, this is instantiation, new person is instantiation, followed by now followed by the class definition. So here in the class definition, what I am doing is, what is my purpose is to implement this particular eat method. Okay, so now I am implementing that. So how to implement void eat, and we have to provide some behavior, that's it. So now I am saying, so person can eat, but what he is eating I am just giving over here, system.out.println, let's say eats, I am saying eats, person eats fruits. Okay, I am just giving some random behavior for this particular person. Okay, so now if you observe, so this is the implementation defined in the anonymous inner class. This class has no name, but it has a method, and this class is getting instantiated because new operator is there, but I am actually making use of person class because my intention was to implement the eat method. So eat method is there as part of my person class, which is abstract. I am implementing that. Okay, so now this new person actually can create me an object, right? So in order to refer to that object, actually I'm having a reference variable. Let's say person P1, person P1. So the anonymous object is now referred by P1. Okay. Yeah. So now what is this person that we need to understand? So this anonymous inner class implements this eat method, which is an abstract method of this person class. And my intention was to implement this eat method. So now I am instantiating this class and referring to P1, and P1 is of type person. So we know in Java, parents can actually refer to their child objects, right? So here, when we are using anonymous inner classes, the inheritance comes into the picture implicitly. What actually happens is this anonymous inner class that we are defining here extends this person class, and provides the implementation for this eat method. And because this class has now become parent, so parent can refer to the anonymous object. Parents can refer to this anonymous object. Okay, that's why P1 type is person. So we are done actually. So anonymous inner class has been defined here. So this is the process of instantiation plus class definition. We are done, and object is getting created, and the object is referred by P1. So with P1, what actually I can do is, because I have an object in my main method, what I'm doing is P1 dot eat. So I'm just calling for this P1 dot eat actually. Method is there, and I'm calling P1 dot eat. Actually, it should provide me the implementation details of the eat method. The eat method is telling us the person eats fruits. Okay, so now let's see. Yeah, so I'm done with my anonymous class, then my main method and my class as well. Okay, so let me save this person class first. Yeah, it's saved actually. Let me compile. So Java C person.java is an abstract class, right? Yeah, compiled successfully, there is no problem. And let me compile test.java. Java C test.java. Cannot find symbol test actually. So let me save this test actually. So because it was already saved with other implementation. Yeah, so now we will not get that error. Yeah, Java C test.java. So successfully compiled. So now when I say Java test, what happens? An anonymous inner class is getting created in the main method, which is extending the person class and providing the implementation for eat method. An object of this anonymous inner class is created and referred by P1. Through P1, actually I am accessing the method which was written in the anonymous class, that is eat. So when I say Java test, I will actually get the outcome as eats fruits. Okay, so now see eats fruits. So now what is actually happening internally? Let's understand that. Okay, so let me annotate here with some diagram. So now what actually happens is, whenever you say person P1 equal to new person, an object is getting created, and which is referred by uh, P1, which is a local variable in the main method. So that is a main stack, right? So main stack is going to get created, and which has a local variable that is P1, and this P1 is of type person, right? So it is of type person, and this is actually referring to, this P1 is referring to an object of not person, an object of anonymous inner class. Okay, so this object is created for anonymous inner class. So that is not person class. You know, anonymous means nameless. So anonymous, a nameless inner class has been defined over here, and its object has been created, which has no name but referred by P1. Okay, but what this anonymous inner class is doing, this anonymous inner class extends this person class and provides the implementation for the abstract method of this particular person class. Okay, and we know abstract classes can refer the objects of their child classes. That means the implementation classes. So now P1 can refer to the anonymous inner class. So this is actually happening inside the GVM. Okay, so this is an example with the abstract class. This is an example with abstract class. Now actually I can make this as an interface as well, because interfaces will contain all abstract classes. Interface class person. Now I need not to specify for an interface. See, interface is a keyword and I must be small. So interface person, interface person, and interface contains all method declarations. Let's say void it. So by default it will be public abstract void it. Okay, and we can actually have other methods as well. Let's say void speak. There is another method also. A person can speak, right? Yeah, so this is also public abstract void speak. By default, interface, all the members in interface are public members, right? Now this interface person has two methods, void it and void speak, and interface will only specify the functionalities, not the implementations, right? Now what should happen? There should exist some class that implements this person. So class A implements person. Now it is the responsibility of the class A to provide the implementation for this eat method and the speak method. And objects of that class A can be created and eat and speak methods can be called, right? And this interface person can actually refer to the objects of its implementation class. So that we know already, right? Now what we do is we'll create an anonymous inner class, not some class A, anonymous inner class, which implements this person and provides the implementation details of an eat and speak methods. Okay, so let's now do that. So now I'm doing the same thing in the test class. So before that, let me actually compile this interface. So earlier it was an abstract class and I have changed its behavior. So Java C person.java compiled successfully. Now I can go to test.java. So now here what I'm doing is public class test in the main method. Now I am defining actually anonymous inner class. Okay, so interfaces can refer to its implementation class objects, right? So now your interface is person, p1 equal to new person. I am not actually keeping the semicolon. If I keep semicolon, it's wrong because interface cannot be instantiated. Now this is the definition for anonymous inner class. And void it. So because now person becomes interface, so it must be public void it, because in interface all the methods are public. If I'm not keeping public, compiler will generate me an error saying um, I am giving I am insufficient privileges, a weaker privileges to this particular method actually. So that's why it must be public void it eats fruits, and this is one method, and there is other method also. Now this anonymous inner class will provide implementation for all the methods of that interface. So public void speak. Okay, so now person speaks, right? So what he is speaking? He's eating fruits. In the same fashion, he can speak, and he is speaking some language, right? So speaks, let's say English. The person speaks English. Okay, we have provided the implementation, and I'm done with my uh, anonymous inner class. Now anonymous inner class definition is like this. It is actually providing the implementation for eat and speak methods of interface called person, and person can actually refer to its object, and the definition and instantiation will happen here. And p1 is an object of anonymous inner class which is of type person, because interfaces can refer to their implementation class objects. So that is possible. So internally what actually happen is anonymous inner class implements the person interface, and it is will get instantiated, and this object is referred by p1 which is of type interface person. Okay, so once it is done, I can actually call p1.eat and p1.speak. Okay, so let me save this and compile. So Java C test.java. Yeah, we have one problem actually. p1.speak cannot find symbol. So let me actually go here. Void speak and test class. Yeah, let me check the error over here. Cannot find symbol p1.speak. So let me compile this once again, because this test.java I am saving it once again. So I think it might not have got saved properly. Java C test.java, and again I'm getting p1.speak method speak variable p1 of type person, public void eat and public void speak system.out.println speaks English, and my person interface has both. Let me save this. So let me save this. I think this is a saving problem. Java C person.java compiled successfully, and Java C test.java and compiled successfully, because earlier the person.java has not been saved properly. So that's the reason. So now let's say Java test. Yeah, so eats fruits, speaks English. Now what happened? The anonymous inner class provided the implementation for eat as well as speak methods, and we are actually accessing these methods through P1, which is of type interface, and we could able to get the outcomes as well. We can actually see here. So eat actually behavior is eats fruits, speak behavior is speaks English. Okay, so that is the purpose of anonymous inner class, because we have a number of interfaces and a number of abstract classes, and some class has to implement those abstract methods defined in abstract class as well as in interface. So instead of using a named class, we can actually use an anonymous inner class which can provide the implementation for those methods. So we can straight away write them in any method. So we usually do that in the main method, because the main program execution in Java starts with the main actually. Okay, so this is the main purpose. What can be done is we can actually override the methods defined in a class as well. So for example, if this person is my class person, for example, this class person has some eat method, and this definition is already there, because classes will have the implementations, right? Classes will have the implementations as part of their methods. That's why they are concrete methods. System.out.println, and here I have the implementation. So a person eats uh, system.out.println. So now what is the behavior? This person eats actually. So what he is eating? System.out.println eats. We can actually say anything. So cookies. So this person is eating cookies. Yeah. So now here the same, because we have another method as well. So here I can define this method behavior. So and this person speaks actually. So let's say what he speaks. Let us assume he speaks Hindi. He speaks Hindi. The person speaks Hindi. So this is a class actually. Person is having all concrete methods. So there is no abstraction here. Okay. So let me save this. Java C person.java compiled successfully. There is no problem. Now this is a concrete class with concrete methods, right? So now let me go over here. So now in my public classes, as part of my main method, I am actually writing anonymous inner class. Now what actually it is doing? Now it is overriding. Okay, already behavior was there, so we can actually override. So we are overriding the eat method, and here it is overriding the speak method. Okay, so anonymous inner class can extend this person class. Now this person class is a concrete class, and it can extend this person class and provide overridden behavior for this particular methods eat and speak. So here eats fruits and it speaks English, right? Yeah, speaks English. Now p1 dot eat and p1 dot speak actually. So the original behaviors actually eats cookies and speaks Hindi, but the overridden behaviors by this anonymous inner class will be eats fruits and speaks English. So let me compile this test class and show you. So Java C test.java compiled successfully, and whenever I say Java space test, then eats fruits and speaks English. This is the anonymous inner class uh, behavior, right? Now in order to verify that, so what can actually happen is, so in main method I can actually create my person objects also, right? Because person is a concrete class. Now I can create objects of the concrete class person. So person p equals to a new person. Now a person object will get created. So that this is the direct object of the person. This p is not anonymous inner class object. Now what I am doing here is I want to find out its original behavior. So p dot eat and p dot speak. So now what actually happens? Eat and speak p1 is of type person but referring to anonymous inner class object, but p, which is referring to the person class directly. So p dot eat means eats cookies and p dot speak means speaks Hindi. So like that we have to see the behaviors when we execute this particular class. Okay, so let me compile this test class. So compiled successfully, and when I run, yeah, so eats fruits and speaks English. This is anonymous inner class behavior. Eats cookies and speaks Hindi is a direct person class behavior. So this is how the anonymous inner class helps us in implementing the abstract methods and overriding the concrete methods of classes. Right? So anonymous inner class is so much beneficial in a way to implement the methods of abstract class and interfaces, because the abstract classes and interfaces cannot be instantiated. Okay, and it combines the process of instantiation and class definition. So internally what actually happens is an anonymous inner class will extend a class or an abstract class and provide the implementation for those methods. And if it is an interface, the anonymous class implements those abstract methods. Okay, and an object will be created of type anonymous inner class, which has no name but it can be referred by its implemented types, that may be abstract class, interface, or a class. Hope you have understood anonymous inner class clearly. If you understood properly, please like, share and subscribe to my channel. Thanks for watching. Thanks for your time.